I was born in New Jersey, but I grew up in Saudi Arabia, and I think that's really where I grew this fond attachment to these desert, arid climates. During an internship, actually, at Lamont-Doherty Earth Observatory during the summer of 2009, I did a small project here at Mono Lake, and I fell in love with this place. And I saw the promise that it could have. And I'm trying to uncover the history of the ancient Mono Lake, trying to understand how the past lake levels can give us some clues as to how to prepare ourselves for future climate change.
Hydroclimate change is very important, a very important aspect of the paleoclimate record, changes in the precipitation evaporation, but it's also an important aspect of modern existence, right? Water supplies, especially in arid regions like that, water supply is very important. And so it's at least partly motivated by the need to understand longer timescale records of the relationship between climate change and hydrological change in order to inform our decision making for future water usage in the western U.S. And Mono Lake is a poster child for the sort of competition between maintaining beautiful areas and maintaining the need for water supply.
Los Angeles began taking water from the streams that feed Mono Lake in the 1940s, diverting it into the Los Angeles Aqueduct and sending it 340 miles south to the growing city. By the 1980s, Mono Lake had dropped 45 feet. The salty, alkaline lake water grew even saltier and more alkaline. Limestone towers called tufa, which form under the lake's surface, wound up on dry land. Stream beds dried up. There are no fish in Mono Lake, just algae, tiny brine shrimp, and hordes of black alkali flies. Millions of birds migrating along the Pacific Flyway stop here to feast on the shrimp and flies. The changing lake chemistry threatened that, too. Environmental groups, led by the Audubon Society and the local Mono Lake Committee, sued the Los Angeles Water and Power Authority to restore the lake, and they won. By the 1990s, an agreement forced Los Angeles to cut back the water diversion. LA now takes just over 2% of its water from the Mono Basin, less than 1/5 of what it once took. The city has also undertaken an aggressive conservation program. The lake level has started to recover and is now nearly halfway back to where it was before the diversion. But the American Southwest has been in a drought for several years. Over the past 2 years, Mono Lake has dropped more than 1.5 feet. If the lake shrinks back several more feet, Los Angeles would be cut off altogether. Meanwhile, a more significant water source for LA and other Southwest cities, the Colorado River and its reservoirs, including Lake Mead and Lake Powell, have dropped to historic lows. To plan for the future, it's important to understand exactly how climate affects Mono Lake. Researchers have found evidence of prolonged droughts in the past that lasted 100 years or more. Terraces that stand high above the present lake mark the ancient shorelines. Where streams have cut channels into the land, thick layers of sediment, volcanic ash, and gravel record Mono Lake's history.
There's volcanoes in the basin, and in the sediments that he's studying, there are 19 volcanic ashes. And the importance of this is that volcanic ashes are timelines. And if you can recognize a volcanic ash in different parts of the basin, then you know you're at the same time, and therefore you can evaluate the environmental effects at a particular time in the basin. The other breakthrough is that we have now found that we can get extremely good uranium series dates on very clean, white, dense calcite tufa, and that places an age and a lake level together.
What we really look for are these coatings that coat the tufa. And these coatings are what we think are remnants of algal deposits. This gives us the best ages that we can get.
The reason it's really important to get an extremely highly resolved climate record in any place, in any one specific place, so this is one little basin in eastern California, but what we'd like to be able to do ultimately is to treat the paleoclimate record somewhat like we can treat the modern climate record, the sort of pattern of weather. What is it like in the winter? What is it like in the summer? When does the rain fall? What is the temperature contrast between the winter and the summer? Those are the things that are really important in the modern climate. They're important for agriculture, water supply, and therefore, and we'd like to understand what increasing greenhouse gases are going to do to the future.